we move to the last talk, also from Iwan before lunch. He gonna talk about, no, I don't want to give you a pressure, and new Pico Event Timer for space applications.
I'm sorry to delay you from your lunch. I will try to be as fast as our detectors are. And again, I would like to mention my colleagues. And I have presented our timing device several times, and just why I'm presenting again, because as you have seen, there is no need, new need of very stable timing system for laser time transfer. We are talking about the fraction of picosecond for the long term and so on, and on both ends, on ground and in space. And there was a strong interest in European Space Agency when preparing the ACES mission with European Laser Timing, ELT, on our device. So there was a lot of question how we can make it spatially qualified. So this is the ground version. Photo is 10 years old. This is the existing new Pico Event Timer. This is the abbreviation of NPET. And what we have done, we have just testing what will happen with this one if we will radiate it. Okay, so this is the status quo, the ground version of the new Pico Event Timer. The jitter is below 500 femtosecond RMS. The nonlinearity, temperature drift, everything is small hundreds of femto. And the long-term stability in the sense of time deviation is well below 4 femtoseconds. And it was presented many times. It's covered by US patent and blah, 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 blah. It is working. Nothing is cheap. Nothing is free of charge. You have to pay. The maximum repetition rate of measurements is limited by principle of the device, not by the interface, by principle to units of kilohertz, units of thousands of readings per second. The dead time is very long, of the order of a fraction of millisecond, and it needs extremely high quality input clock signal. You cannot put any 100 megahertz and expect these values. No, you have to use. Okay, so I will not spend too much time. So, but it is existing, it is working, and it is installed and used on numerous sites worldwide in different institutions which are interested in precise timing. And these are different versions. This is the portable version used by ESA for calibrating European laser timing project. And these are standard REC, 19-inch REC mount, single channel, 2-channel. This is single channel with 32 input switches version and many others. We were thinking, and we even made a mini project to make a study what will be how difficult it will be to make it completely out of space qualified components. The good news is that all the components space qualified needed for such a device are existing. It means the device can be in principle built. However, we did contacted 2 companies with space qualification about time and cost, and you see this is not very, both numbers are not very nice. So what we decided to use what we do have, the existing device, and try to radiate it as it is. What will happen? And we just put it into the small aluminum box, and it is doing the radio frequency shielding. It is helping for passive heat distribution. Unfortunately, it does not make any radiation shielding. And we did organize a radiation test with cobalt-60 standard, ESA standard for radiation test of electronics. Beginning of this year, these are the underground labs of the Institute of Radiation next to Prague. During the tests, radiation exposure, the device was completely operational. It was running in the self-test regime on 1 kilohertz rate. The radiation direction is marked by this pointer. And obviously, the 100 megahertz clock source, I mentioned it is not a trivial thing. Power supply, a control PC were located outside the radiation chamber, obviously. And this is the source of the radiation. This is the block with some additional shielding to adjust the radiation flux to the desired value. And this is the short history. The radiation started on the left-hand side, and these are the last days. In the day number 18, the first communication problem appeared, but it was still working, but not as good. However, it stopped to provide any results after 20 days of radiation flux. Nevertheless, we stopped the radiation after 22 days with a dose of 75 grays. Once again, this is just a review about what I was saying just now. But what is important, after finishing the experiment, the device was taken back to the lab, and we did study what did happen, what was killed. And there was a good news. Only one single chip was killed, and the chip is not needed. You could not dream better than this one. There is a switch which is controlling what kind of output format, or what kind of control interface you are using, or RS232, with the levels plus minus 6 volts, or low voltage TTL. And if you will switch to the low voltage TTL, bypassing this single CMOS circuit, everything was working. And immediately after that, we did start the test of the device again, and this is the timing precision in the sense of time deviation. 1 attosecond is here, 10 to the minus 15. Femtosecond, 10 to the minus 15. 1, 2, 3, 4. 4.5 femtoseconds after 100 seconds, and it is stable about many hours, better than 6 femto. It means the device is working after the rather strong radiation. The summary, it survived the radiation dose of this amount. This amount corresponds to operation on LEO for several years if no additional shielding will be applied. And for routine space operations, the board will be slightly modified if there will be interest. We will add a simple trigger circuit on the input, and we have to redesign the board to survive mechanically in space, because now it is just flat board and it needs follow some rules. And we do plan to, after modified, we plan to repeat the radiation test without this one tricky circuit, and we do expect much higher radiation resistivity of the new device, but will be absolutely no modification of the timing hardware itself. Okay, the new Pico Event Timer may be relatively simply adopted for operation on board for laser time transfer and similar mission. And thanks.
Do we have something from audience for Ivan?
They're going to make some vacuum tests for space readiness check, because as I understood, you did only the radiation test, yes? But what about deep vacuum tests?
Which one?
Vacuum.
You are absolutely right. But remember, at the university, with absolutely minimum budget, we just tried the most questionable test, the radiation. We are not going to any space mission. We have no order for the space device. It was just our own initiative. You are absolutely right.
Yeah, because from our experience, even if you'll get good results for the validation test, just
There is
the
no question.
vacuum will
There is
damage your device at all. So there's no way to launch.
There is no question that it must be done, including the mechanical rebuild.
Yes,
but
yes.
what is good for us that we do not need to restart the design and construction of the new electronics.
Okay, thank you.
Okay, well, we're going to go to lunch. Thank you very much, Ivan. Thank you. We have 4 more talks in this session coming, so please come back at 2:30 so we can start. Thank you.